let's really distinguish the difference between a sample and a population. And to be clear, when I say population, it's not everybody in the world, unless the whole world is truly what you're trying to study. If you're just trying to study cockroaches, then cockroaches is your population. And in most cases, populations are very large, and you don't need to survey every single individual in the population just to get a good sense of what the real world looks like, or to get a good sense of what you're trying to measure in the population. It is sufficient to just sample from that population. If the population is large and your sampling method is legit, then the information in your sample should be pretty good or pretty close to what you're trying to measure in the population. Why don't we just sample every single individual in the population? First of all, it's usually impossible, especially when the population is super large. And number two, it's costly. Are you willing to pay that much to survey every single person? Can you actually reach all these people? So it's impossible, it's costly so far, and it's time consuming. So you could spend all this time surveying all the people when all you need to do is survey enough people, and then you're off to your labs to analyze your data. Right? Or do you want to spend time analyzing data, or do you want to spend time surveying every single person? And the last one is overkill. So I'm sure you're already getting a sense of that. It's overkill and unnecessary. So for those reasons, we don't survey, in most cases, don't survey every single person in the population. You just sample from that population. So you want to draw a large sample. It doesn't have to be a super huge one, but a large sample should be sufficient. And secondly, the statistics in your sample is used to describe or infer about the parameter in your population. A population is defined as all people or all items with a certain characteristic that you're trying to understand more of. And what you're trying to measure in the population is called the parameter. And the sample, as you know, we draw a sample from that population of interest. So the sample consists of only observations or subjects drawn directly from that population. And the information in the sample is called the statistics. Since we're not surveying every single person in the population, we don't know the value of the parameter. But the sample is right in front of you because you've drawn that sample. So you have information called the statistics, and you're using that to estimate or infer about the population that's usually unknown. Here are some examples of notations or symbols used for parameters and statistics. The population mean is represented by mu, and the sample mean is represented by x bar. Or in some courses they use y bar, same thing. That's cool too. I prefer x bar. And the standard deviation of the population is represented by sigma, and then standard deviation of the sample, s. Okay, I know some of these symbols might be intimidating, especially when you just started this course, so don't dwell too much on these symbols. The reason why I'm showing you this is because notice that the parameters are usually Greek letters. Not always, usually. And then the sample statistics are in lowercase English letters. Again, not always, but usually. So when I lay them all like this, you can see that Greek letters are in the parameter column, and then the English letters are in the statistics column. Again, not always. A sampling frame is pretty important. Especially when you have a large population, you may not have access to all of them. Again, you don't have to sample everybody in the population, but you do want to have access to all of them, because when you randomly draw from that population and you only have access to a fraction of it, then those who are not available to be drawn will not be part of a sample, will have no chance to be part of a sample. So your sample may look wonky, or in proper terms, your sample may not be representative of that population, especially when the sampling frame is very limited. So to give you a visual, let's say this is a population. And my sampling frame is only here. For some reason, I don't have access to green people, whatever that means. So I can only draw from my sampling frame. And my sample will only contain people in the sampling frame, not the people that's not available to be drawn. And that's problematic, especially when the sampling frame is very small or a small fraction of the population. So let's say I want to sample all students on campus, but I don't have access to any law students. So maybe there's some rule that I can't survey law students. But my population of interest is all students. So my sample will contain most people, but it certainly will not contain any law students. So that is problematic. So that's what happens when the sampling frame is not equal to the population size. So it's ideal when I'm able to draw everybody in the population, but the sampling frame may be a limitation. Examples of sampling frames is an HR database, a street map, telephone directory, and so forth. A census is data collected about every individual in the population. That is the only time when you actually have information about everybody, assuming no one is accounted for. Right? Realistically, I'm sure there are a couple people who are not accounted for, but let's keep it simple. A census is data that's collected from every single person in the population. Okay, so usually the government has that information.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.